Error. Am I audible, guys? Is my voice clear? I will just check it. Am I audible, everyone? Is my voice clear? Am I audible and visible to everyone? Please say something in chat like if I'm audible. So I guess I'm audible, right? So let's start. Okay, thank you. So today's topic would be linked list. Uh, we would continue from where we stopped the last class. We had two sessions already on linked list. We solved a few interview problems. We'll be continuing from that. So actually this class was scheduled for yesterday, but because of some technical difficulties, I was not able to conduct the class. Hi Pawan. Uh, so this will be a continuation of the last class we had on Wednesday, I think. On Wednesday or yes, I think Wednesday. So let's solve a few more interview problems on linked list. Okay. So this will be the first problem for today, which we will solve today. What I will do is I will send you the link in YouTube chat also. Let me just- You can go to the problem on my screen. I will also send the link. Just give me a second. So I've sent the link in chat. Yeah. Okay. So what the problem states is that you are given a linked list, a singly linked list. We have to return true if it is a palindrome. So this linked list you can see is a palindrome 1, 2, 3, 1. It reads a palindrome is nothing but a number or something, a string or whatever it is, which reads same from front and back. So it is 1, 2, 2, 1 and 1, 2, 2, 1. So this 1, 2 is not a palindrome because it is 1, 2 from the front and from the back it is 2, 1. So it is not a palindrome. So you have to, so given a linked list, you have to return if it is a palindrome or not. Okay. And the expected time complexity for interviews would be an O of 1 time and O of 1 space. You can solve it in like a lot of us. You can just convert it to array and do it and check for palindrome. But what we want is to solve it in O of n time and O of 1 space. Okay, this is important. So how do you think we can start approaching this problem? So given this linked list, let's say this is also a palindrome and it is null. So we can use an English and this is also a palindrome. This is a palindrome of odd length, this is a palindrome of even length. These are only these are odd length. But both of them are palindromes. So how can you check if the linked list is a palindrome or not? The main thing note here is we are going in linear time and constant space. Like several brute force algorithms are there, but we are interested in something like this. So think about it. So I will give you some time to think about the problem, how you can optimize it. Maybe you can tell your approaches in chat, what you are thinking, how you can optimize it, and I can help you move in the right direction. Yeah. Anyone? Take your time, take 2 minutes, think about it. No hurry. So okay. Yeah. So hello, okay. So reverse the linked list. By that you mean I have this list one, two, let's say one, just for. So you want to make a reverse of this linked list again. So want to maybe let's say it is not a binomial. Let's take a counter example. Let's say it was like three. So you want to do like this, but if you want to check both of them, then you have to make a copy of this linked list. That means you must have this linked list and you also need to have this linked list with you again. That means you must have two copies of the same linked list. So if you keep two copies, then this linked list would take up O of n space. Then you will just traverse through both of them and check on them. Right? But we are doing it in like O of n time and O of n space. So you take go to meet and take two pointers forward and backward. Okay. How that will go? Maybe like this. Okay, I go here. Maybe let's take an even length palindrome. For So I do like this. So I go to mid now. Now I have to check from this side and this side. How can I check from this side? The linked list is only to this side, on the right. I can move from this node to this node, but I have to actually move in the reverse direction. This direction. How can I do that? Yeah, you are like close to a solution. You have to go to the middle of this linked list, but from here you have to do something so that you can uh, check from this side and from this side. If you can check from both of the sides like together, then the problem is solved. So how can we check from the reverse side? Think like this. Think like this. You have this linked list, few nodes. You have got to the like this list. You got to the middle. This is say the middle node. Now you have a pointer to this middle node, and you want to check from this side one, and you want to check from this side one. How can you do this? The by accessing this mid pointer directly, you can maybe go to mid next. That means like to this side, but that will not help me much. I want to go in this direction. This is most important. How can we do this? If any one of you can do this, then the problem is solved. The keyword is go in the reverse direction. Reverse direction. The answer is there in this word. Anyone? Okay. So what I will do is, maybe I will tell you the solution then. So the idea is, we will go to the middle of this linked list here. Now this entire part we will reverse this linked list. We will reverse this portion of this linked list, the right arm. See, if we reverse this, we are going to have something like this, and this middle half, where all these nodes will be pointing like this. So now we can traverse from this side and from this side and go up to the middle and check if both of them are equal, right? So it will work, right, guys? Have you understood it? How, like, what we can reverse actually? We can reverse the second portion of this linked list. So if you take an example, let's say for here, let's say we have an example like this: one, two, one, and so initially I will go to the middle of this linked list, and what I do, I reverse this node. So one will be pointing to 2, and now this will be pointing to none. Okay, and this will not point to none maybe. And now, so reversing a linked list is O of n time. You know that. Reverse a linked list, you can do that in linear time. So it will be O of n time only. And finding the middle. Step 1 is like find middle. Find mid, which is O of n time. And step 2 is reverse second half. That is also O of n time. Right. And now step 3 is nothing but compare. Step 3 is to compare. So now you can take 2 pointers from here and here and just compare all the values. If the values are not same, then it is not a palindrome. And after that, Ultimately, if you come to null, it means it is a palindrome, right? So isn't the solution simple? So any doubt, anyone? How we can solve this? Any doubt regarding the solution? If you have any doubt, tell me. So let's look at the code maybe, and we have to understand it better. So how do we first find the middle of this linked list? For that, I will use a slow and a fast pointer. The slow pointer is going to move one time, and fast will move two steps at a two nodes at a time. And ultimately, when fast will move towards the end, slow will be at the middle because slow is moving at a half speed of fast. So I take two pointers, slow and head. So this is while fast and fast next, so that I can move fast two steps. Slow is going one step, and fast is going two steps. Now after this loop, slow is at the middle of this linked list. What I do is I reverse this second half of this linked list. Slow equals to reverse slow. So I now reverse the second half, and now I like while slow is not equals to null. This just means that not equals to null period. If head value not equals to null, that means if both the values are not same, return false. It is not a valid node because I'm checking from both ends. And, and what I do, I just increment the head and slow pointer by one every time. Ultimately, if this loop is complete, it means that I have checked that this is a palindrome. So I return, right? How to reverse a linked list? Reversing a linked list is the pretty standard algorithm which we use. Take this previous node and a temporary node, and so I guess all of you know how to reverse a linked list. If you don't know, I'll just tell you maybe here briefly. So I take a previous node as null, and this head node is given to us. So what I do, I copy the head next value, current head next value, in a temporary pointer. I store this node, and on this head node, this head next, I just reverse this node. So it's like how to reverse. If I show it to you, maybe I will. Maybe let's say we have this linked list 3, 2, 1, and null here. So what I do, I keep a previous value equals to null. In the temporary node, I am going to store this value 2. And what I do, head next, because this is the head node right now. Head next equals to previous. That means this null is going to be the next of 3. And then I update this previous pointer to point here. Previous will now point here, and head will now point to this node. Okay. So now again, I will store this in temporary variable, this one. Head next equals to previous. Previous is 3 now, and head is 2 now. So head next equals to previous, and now like this, the entire list is reversed. Okay. So this is a pretty standard algorithm to reverse a list. And at the end at the end, when I have this reverse linked list, ultimately head will be pointing to null, and previous will be pointing to this head of this linked list. That means this list 1, 2, 3 null. Previous will be pointing here. So basically, previous is going to be the head of this linked list now, and head will point to null. Okay. So I have to return previous, the head of this linked list. So it is clear, guys. The solution is clear to everyone. Like how we can solve this. Write something in chat, maybe yes or no, or if you have some doubt, you can tell me. If you have no doubt, then we'll go to the next problem. Any doubts, anyone? Okay, so I guess no one has any doubt. So let's solve this problem now. This is the second problem which we'll solve. intersection of two linked lists. Okay, I will send the problem link in chat. So this will be the second problem. Okay. So what the problem states is that we are given the heads of two singly linked lists, head A and head B. We have written the node where the two linked lists intersect. If there is no intersection at all, return none. So what we are given here, we are given the heads of these two linked lists A1, that is A and B, and we see that these nodes intersect at this node C1. This C1 is the point of intersection. So I have to simply return the pointer to this node C1 here. Okay, and it is given that it is guaranteed that there is no cycle anywhere in the entire linked list. So there is no cycle here. So you don't have to consider the cases for that. And also we can't modify the given linked list. Note that the linked list must return the original structure after the function returns. So we can't modify the values or the pointers in this linked list. Okay, like we cannot change this linked list. So if we have this linked list 4 1 and this two linked list, this head A and B is given, we have to return 8 here because they are intersecting at this node 8. Okay. If this linked list is given, the answer should be 2 because they are intersecting at this net at this node 2. This is the answer. So this linked list, there is no intersection. So what we return to, like we put a null. Null means there is no intersection. So it will print no intersection. We put a null in case of no intersection. Okay. So this is what the problem says. So we want something in linear time and co-op on memory. That is like our target goal. But first, let's try to solve this problem. So, how do you guys think we can approach this problem? How can we like have at least one solution for this? Like, forget about optimization. Like, what will be the first approach which comes in your mind? Yes, anyone? Write in chat. Try to interact. Like, write what you are thinking. If you can solve it on your own, then it is good. How can we solve this problem, guys? What do you think? So maybe I will give you 2 minutes to think about it. Then you can write in chat what you are thinking. So you just need to return the pointer for this node, not the value. Return the pointer for that node. Like you return the pointer to this node 8 in this case. Pointer to this node 8 and null here. So anyone? Come on, write something like what you are thinking. Like I'm trying that so that you can solve it on your own. I can obviously tell the solution, but the goal is like if you can solve it on your own, like that's best. Okay. So are you guys thinking, or should I proceed with the solution? If you are thinking, then tell me. I will give you some more time to think. Otherwise, let's proceed to the solution. Okay. So let's see. Let's see. So if we have um, some linked list like this, and let's react for and then yeah, okay. So we have something like this, and we want to find this pointer to this node. So what you can do is the brute force approach would be take the point. You have the pointer to this node A and pointer to this node B. So brute force approach would be for every value of B, that means you take B here and you iterate through A and B together from this point and see if they intersect. Now they don't intersect anywhere. If you start from here, like B will move here, next step A will move here, A will move here, B will move here. So they won't intersect like this. Then you can update B to this point and then again check like a linear scan. They won't meet again. Like they will meet now, I guess. Now A will move here, B will move here, A will move here, B will move here, and this. So they will meet eventually if you do like this. But the problem here is that the time complexity is like here it is going to be if suppose the length of the first list is n and length of the second list is n. Since for every value of the node we are checking this is going to take O of m and time. Okay, but we want to do this in linear time. So another way to do this would be let's first find the value of the first list. That means the value of the first list is n and value of the second list is n. That means the length. The length. This is for the first list. This is for the second list. Now there are two cases. The first case would be if the length of both the lists are same. If the length of both the lists are same, what we can do is we can simply go like we know that the list is going to look somewhat like this. Maybe 3 and then 4, and here you can have 5, 0, let's say 7. Since the length of both of them are same, so the list is going to look somewhat like this or somewhat like this. 1, 2, 3 null maybe, and maybe this can be 4, 0, 5. So the list can either be like this or like this. Then what I can do, we can simply uh, start two pointers uh, from this starting node, iterate one by one, iterate these pointers one by one, go here, go here. Ultimately, they are going to meet. If both of them are of equal length, ultimately they are going to meet. like here also they will move like this, and finally they are going to meet at this null pointer. So this two are same, and also this is same. Okay, so if both of them are of equal length, then this is the first case. So there can be another case also. Case 2 can be if n not equals to n. Okay, so let's say here m is greater than n. If m is less than n, you can just swap the pointers of the two lists, and one of them are going to be like one of them is going to be greater than the other. That's the idea. Like m is greater than n, or n is greater than n. So any one of this, but let's consider this and check. So if m is greater than n, so what is going to happen is the first list A is going to look. I'm just drawing it like for your understanding. I have to understand the concept actually what I'm trying to say. The first list can look somewhat like this, and the second list can look somewhat like this, right? So maybe you can just represent a linked list like this, 3, and here you have got 4. Maybe after this you got none, and maybe I've got like 7 here. After this you have got this. So this can be this linked list. This is the intersection point. So I'm saying that the length of this first linked list is m, and length of this linked list is m, second one, and m is greater than n. So what the idea here is, you can find the difference between m and n. You can find m minus n. Okay, that means m minus n is going to be this distance, right? This is going to be m minus n, right? Find this distance. Now move a from the head of this linked list to this point. So if you do this, now A and B are going to stand equidistant from the point of intersection, that means this point. So you can easily find the length of this linked list by iterating once. Now m minus n is difference, so you move A at this point. Now A is pointing here and B is pointing at the start of this linked list, second linked list. Now A and B move one at a time. A moves like this, B moves like this. So ultimately they are going to meet at this node because they are equidistant. Okay. So do you understand what I'm trying to say? Like first find this length, then the node which, that means the list which has a longer length, you move that pointer m minus n steps from the beginning. A has a longer length, right? So you move it here. Now they are going to be equidistant. Now just move both of them and they will meet at this intersection point. So what will be the time complexity for this? To find the length of m and n, so it would take O of m plus n. Find both of their length and then do this. So it would be the time complexity. Okay. So you can do this approach like this, like a linear approach, and the space is going to be also 1, 2 of 1, right? Because you just have these two pointers A and B and nothing else. Just iterate once, iterate twice, third time, go and find it. Correct? So this can be a solution, but we have a better solution. Like this solution is good, obviously. This is already optimized. This is optimized solution. But this solution takes more lines of code. It turns out that we can do something better, like something more intelligently, and reduce the lines of code for our solution. So just stick tight. Let me just explain to you. So that the idea I'm going to explain is going to be similar to this only, which you saw here, but just it is going to be a bit optimized for coding. So the idea is like this: if you have a linked list like this, say I'm just trying to explain you the linked list as a line, but it is a linked list. I hope you can understand that at least. So A is pointing here, B is pointing here, and this is the point of intersection. Okay, and now it is null here. Now you know the length of the first list is m and length of the second list is m. Okay, what I do, the idea is iterate A and B through this entire list. So initially A is here, B is here. Iterate one by one. Iterate one by one. Now when say B is at an advantage, right? Now you know one thing. This distance is going to be m minus n, right? M minus n. This is the distance m minus n. That is, you can see, because the length of the first list is m and second list is n. So this is m minus n. Now when B will be at this point. Now when this pointer B, like let's say this is as pointer B and this is as pointer A. Just taking a copy of those. Now when PB is going to stand at the end of this list, where will PA stand? PA was m minus n steps behind B. So PA is going to stand here, and this distance is going to be m minus n, right? Right? Is it clear, guys? So they will be at this point, standing at this point when B is at the end of this list. Now what I will do? I will do something intelligent. I will move B after B has appeared at the end of this list. I will move B towards the front of the first list. That means I will make B point here. Now B is going to point here. After B traverses the entire list, B is going to point to the beginning of the first list. Okay? And now continue your journey towards the end of this list. So what will happen now? Now PA is going to move here, and along with PA, PB is also going to move. So if PA was here initially, PA was here and PB was here. Now PA moves this distance, PA comes to here. So PB will also move m minus n distance. So now PB is going to stand here. Okay. So PB is going to stand here. PA is going to stand at the end of this list. So now we have something like this. Now what I do, since A have finished iterating the entire list, now A will point to pointer B. That means A will point here. B is pointing to A and A is pointing to B now. Now A will point here. Now is it clear? Now this distance and this distance will be same, right? Because they are standing at this point, they are standing at this same distance from the intersection point. So now if PA and PB moves one step at a time, so they will eventually meet at this point, right? Can you see this, guys? Why it is happening? Because they are standing at this same distance from the intersection point. They are standing here, both of them. So is it clear? Why? Now just iterate PA and PB like just like while PA not equals to PB, PA equals to PA next, PB equals to PB next, and they will eventually meet at this point. Maybe it is null or maybe it is a node, but they will meet somewhere. Like it can be like this also, 1, 2, 3, and it is null, it can be like this 5, 4, 7 and null. So they will meet here at null or whatever it is. It doesn't matter. So is this idea clear? How we can do this? Start PA and PB at the beginning of the two lists, move them towards the end. When pointer B moves towards the end, make it point to A now. And if pointer A moves towards the end, that means it just reaches the end, make it point to pointer B. Now, when you traverse, at that time you are going to find the intersection. Okay. So I hope like you got this idea, right? This is the main idea of the solution, and this is going to take linear time O of n plus n time. This is the time for you, and the space is going to be O of 1 because you just use these two pointers PA and PB and nothing else. Okay, so let's look at this code. Mm, very simple code. That's why I explained you this solution. Like this code would have been a bit longer. This code is a bit longer, like finding the length and the iterating, but this code is very shorter. That's why I explained. Just look at it. So what I do, I just handle these base cases. If pointer A is null or pointer B is null, this is, if you don't know, this is nothing but theta equals to null period. This equals to head P equals to. If you don't know this, this is just null period. The base case checks. Then I just return null period because one of them is null. Otherwise, what I do, I take one pointer PTR A and PTR B, make them point to the heads of the both the linked lists. So while both of them are not equal, what I do, if PTR A is equals to null, that means PTR A has reached the end of this linked list. Then make PTR A point to the head of the second linked list. Else PTR A equals to PTR A next. Just move it to the next pointer. If PTR B is equals to null, make it point to the first linked list. Otherwise, PTR B will point to the next node. Like it will move one at a time. So ultimately, they are going to meet at somewhere, and when they meet, this loop is going to break, and then it just returns the PTR A or PTR B. It is same as return PTR B. So both of them are same because they are pointing at the same node, right? Isn't this code very short, like very simple? Just the implementation of the idea we just saw. Very simple code, like a few lines, maybe 10 lines of code. So is it clear, guys? Have you understood this solution? Everyone, is the idea clear? Write something in chat, like write yes or no, whatever. If it is not clear right now, if it is clear, write yes. I am following the chat. You can write your doubt in the chat, or maybe you can write yes. No. Okay. Okay, Aditya, thank you. So this was a very nice problem, and it has been asked in interviews a lot of times. This is the problem. You can find the link in chat. I have sent the link already. So now let's look at a different problem. Now look at now let's look at this problem. This is copy list to stand-up pointer. This is a very popular problem. Again, this has again been asked later. So I will send you the link just for you to follow. Let me just share the link here. Yeah. So I think I've shared the link in chat. Go to that link. Maybe you can watch in the screen also. So I'm going to tell you what the problem says. I'm not going to let you read this entire thing. You can read it later. What this essentially this problem says is that you are given a linked list. I am going to explain it to you here. So I second 7, 13, 11. So let's say you have a linked list like this: 7, 13, 11, 10, 1, and then none. So it is said that every node has two pointers, a next pointer and a random pointer. So you can say that the structure of the node looks somewhat like this. If you write like, I will just write this. If you write like start node, it is going to have a value pointer, start node, start next, a next pointer, and start node, start random pointer. Every node has two pointers, so let me just make the bracket here. A next pointer and a random pointer. Okay, these two pointers, next and random, and a value. So this is the next pointer of every node. Like this is the next pointer. I will just write here for your understanding. Maybe let's say this means the next pointer, and this means the random pointer. So what is the random? Why is random pointer pointing? Now the random pointer of 7 is pointing to null. So 7's random pointer points here. 13's random pointer points to first node. 11's points to this node again. 13's random pointer. 11's random pointer points here. 10's random pointer points to previous node, and 1's points to the first node. So 1's random pointer will point here, and 10's random pointer is going to point to the this. So you have this linked list. What you have to do? You have to make a copy of this entire linked list. Make a deep copy. Make a deep copy of the entire linked list. So what is a deep copy means? A deep copy means you have to copy the entire linked list into a new linked list, and this pointer should be pointing to the nodes of the new linked list. So you copy this entire linked list like this: 7, 13, 11, 10, 1, and null. You copy the entire linked list and also these pointers. So like you have to copy this pointer which is pointing here, this pointer pointing here, this pointer is pointing to this node, and this is pointing. So essentially you have to make a copy. This is the copy. See, these pointers are not pointing to the previous linked list. They are pointing to the entire linked list, like the entire new linked list. So how do you think we can solve this problem? How can we solve this? Anyone? Think about it. Take 2 minutes time. Take 2 or 3 minutes. Try to think about the solution. Write me if you have any approach in your mind. Write in the comment. Use the comment. Okay. So I would expect some of you to answer maybe like tell me what's in your mind. How we can copy this entire linked list into a new one. So anyone, any idea how we can do this? This problem is asked in interviews a lot of times, and it will be asked again also. This problem is like there is a trick to solve this problem. So we want to do this in O of n time. Okay, and O of 1. See, we need to copy this linked list. To make this copy, this linked list is going to take O of n space. But that that space I don't consider as extra. That is not extra space because I need the space. You can't remove the space. But O of 1 space is for the extra space. Other than this linked list, I don't want to take any more space. Okay. So anyone, any idea how to solve this? Or else I will proceed with the solution maybe. Okay, so I guess let's proceed. So let's take a smaller linked list to understand. Let's say our linked list we have 3 and 7. Let's say our linked list has 3 nodes. 1, 3, 5, and here. And the random pointer is going to point here maybe for this node. Random pointer will point here for this node. We can point here. Okay. So what I can do is maybe I can use a hash map to store all these nodes. So what I will do first, I will have a hash map. So initially I take this node. Initially I create the entire linked list. That is simple. I create a copy of this entire linked list, and while iterating through this list, I make a copy from this first list. I make a copy of this corresponding node of the second list into our hash map. So if you say our nodes are like this, I make a copy of this nodes and I make a copy of these pointers. See, these nodes are in pink. These nodes are in pink, so okay, so let me write it in a different color so that you can see it clearly. So what I can do is map the nodes of the first linked list in this hash map to the corresponding nodes of the second linked list, like this. Okay, so I do this now. Now what I do, see, these are the pointers. These are the actual pointers. These are not the values. These are the pointers. Okay. So now I first build this linked list. Now what you can do? Now go to this node. Look at this pointer. This random pointer is pointing to null. So make this random pointer point to null. This is null. Now this random pointer of 2 is pointing to 1. Now go to this hash map. Go to this hash map. Look up what is the corresponding pointer of this one. This is 1. Now make this point here. Now go to this node 5. Look at the corresponding pointer. 5 is pointing to 1 only. So go to this hash map. Make this lookup. Get the value. Again make this point to this one. Okay. So this is one approach, and this is going to take linear time, and space would be O of n for this hash map. This is going to take O of n space. Okay. But I don't want to wait in. I want to optimize this to O of 1. How can I do this? So the idea here is it is a trick which you should know. So I will just write these notes like this: 1, 2, 3, 5 here. Okay. So I write this note in space. Let's see what I'm doing here. So this is the original linked list. This is the original linked list we had. 1, 2, 5, and ultimately it was null. It was null. Let's say it is null. So what I do is I copy all the values of these nodes. So now for this first node 1, I make a copy of this node. I make a copy node. I write the value here 1, and for every node I copy these values 2 and 5. Okay. Now after I do this, I also join them with the original node. Like this. So these are completely different nodes. This is one node. This is one node with the same value. With the same value. Yes. So you can do this. Like you can do this first. So I first do this. Now the idea here is these nodes, these original linked list nodes are going to have pointers to the previous nodes. So this choose random pointer is going to okay. This pointing here. Um, this node will point here, and this node is going to point here. So now what I want is to copy these node pointers. So that is a trick. How can I do this? See, these are the original nodes. This one, and this one. And these are the copy nodes. 1, 2, 5. So now the idea is for every of these copy nodes, what you do? Now when you are at this node, what I do? Suppose I am at this node. Now I go to the node next, random, equals to node random next. Yeah, maybe you can make a copy of this null also. No issues with that. Okay. So if you look at this node next random, so you go to this. So like when you are at this first node 1, you go to this node next. That means you go to this node and make this random pointer point to nodes random next. That means it is null here. Nodes random is this node and next is null. So basically you make it point here, random pointer. Now you skip this node, and from this node you go to this node. You skip one node and go. That means you are iterating to the nodes of the original linked list, not the copy nodes. Okay. Uh, Now what we can do? Now node next random. That means this next random pointer. This random pointer. Let's say node random. Node random means this node. Go here and next. This is that node. Node random. Next. This is the node. And now you make this pointer point of this node. Okay, so basically you are making a copy of this entire node, entire linked list. So now you go to this node, last node. Here, see node next random. This node's random node. This node's random node. Node random. Go to this node. Random next. Again this node. Node next random is this. Node next random is going to point. Okay. So now you have made this copy of this entire list. Now what remains is to separate these two linked lists. How to separate this linked list? Just iterate through them. See, the nodes at the event positions are the original linked list. That means first, third, fifth. These are the original linked list. And second, fourth, so on. These are the copy list. So what you can do, just iterate through this linked list and just start from this, separate this node. Then from this node, go to node next. So go to here. Now from here, separate this node. Now separate this node. And at last this node. So now after we separate them, see they are pointing to the new node value. That means finally when you separate them, they are going to look like somewhat like this. You separate the first list, you separate the second list, and they have the pointers pointing to their corresponding list. See, this node is going to point to 1, this is going to point to 1. So in the new list, they are going to point to 1 here, and it is going to point here. That means the new pointers and the old list pointers are going to remain same also. So in the old list also, they are going to point like this. Okay. So this is the basic idea here. The trick is for every node, you make a copy of that node after it. So you make a copy of this node here. For this node, you make a copy. You make this copy. For this node, you make this copy. And now you just copy the next random pointers for every node. And these are going to point to the nodes of the new linked list. If you do this, that means next random pointer for this nodes, then you are going to change the random pointers to the new list. Okay. And after finally, you just separate both of these lists. To separate them, then you are done. Your job is solved. So is it clear, guys, how you can do this? Try to, since you are out of time, I will not be showing the code now. Like the time is less now. I think I am out of time. So what I'll do is I will end this session here. I hope you understood it. What you do, you have understood the solution. So try to implement it on your own. Try to see if you understood it. I think you can implement it. Maybe it will take some time because it is a bit complicated. This code is a bit complicated. Take 1 hour, take some time. Try to implement it on your own. I think you can do your own. Okay. So if you have any doubts, you can tell me in chat. Otherwise, I guess we can end this session here. I hope you learned something today. So just to recap what we did here today, the first problem we solved was we are given a linked list. We have to check if the linked list is a parent or not. Okay. The second problem was we are given two linked list pointers. We have to find the point of intersection of these two linked lists. Like we are given this pointer and this pointer. We have to find the point of intersection. The second problem. And the third problem we did was we are given a linked list like which have got next and random pointers. We have to copy that entire list into a new linked list. This is the third problem we solve. So we need to make a deep copy. So we solved this problem. We saw how we can do this. So is everything clear, guys? If you have any doubts till this point, you can tell me. I will stay here for 2 more minutes. You can tell me your doubts. Clear your doubts now. Use the comment section to clear your doubts. So till then, I will just make an announcement about this. So currently, we have a few courses going on in Unacademy. So I will just show this to you, like if they are helpful for you. So we have this first course transfer, which is on the computer fundamentals, like OS, DBMS, and networking. We have this course Ekalabia, which is for beginners. It is on Java programming. But this Brahmasta is a course for campus placements, like off campus or on campus, whatever it is. So if you are preparing for placements, then it will be helpful for you. And Mahayata is a advanced course on programming. Okay, it's an advanced course. Like mainly if you are 4 star or 5 star on code chef or maybe more, then it is for you. So these batches are going to start on like this week, maybe 20th and 21st only. Like all of these batches. So like what is the benefit of joining these courses? If you ask me, I would say that like all these courses have a structured learning path. That means before you start the course, you will be given this entire syllabus, and when you are going, it is not like in a random one. You know what to do next. You are given all this what to do afterward. Like you are given for every concept, you are given a lot of problems to solve. So like it's a structured way of learning. So it is not like any random way. And if you subscribe to Unacademy competitive programming, you are going to get access to all these courses. Like with one subscription, you get access to all the batches and courses in competitive programming. So you don't have to register for them separately. Like if you are preparing for ICPC and code jam contests like this, we also have courses for this. We also have courses, and if you are also preparing for interviews, then also we have courses. I'll show it to you soon. You will learn one of the best educators in India, and the fees is less than rupees 90 per day. It is less than rupees 90. Okay, so I'll just show you this batch syllabus so that you can get some idea about what you'll be covering. So this batch transfer is focused on computer fundamentals. First week we are going to cover, like first month we are going to cover computer networks. Most asked questions from competitors. Then we are going to cover DBMS, and in the third month we are covering the operating system. Okay. Then after this is done, we also have like 2 weeks, a few classes on object-oriented programming. So this is a very important concept for interviews. You can go. Now let's look at this course, this Java course, which is on this particular here. It is a 7.5 months course, like 7.5 months. Okay, and it is starting on 21st July. It is mainly for beginners. It is mainly for beginners. If you are starting with Java, or if you are like 1 month or 2 months, then you can register for this course. So this course is mainly like you are new to Java. What we'll do is we'll teach you competitive programming and make all this implementation in Java. So we are going to be a competitive programmer in Java, and this will help you for interviews also. You can use Java in the interviews for solving the problems. So I will just show you the syllabus. That's your basic idea. So in the first 5 weeks, we are going to cover the basic building blocks of Java programming. If you look at all the programming details of Java, what we have variables, loops, object-oriented programming. Then, then 2 weeks we are going to dedicate to sorting and searching. We look at all the implementations in Java. After that, we are going to have a data structure course, like on the basic data structure, which is important for interviews. Like it will mainly be interview problem solving. That means we are focusing on interviews, and all the implementations are in Java. Then we move on to additional concepts. We look at grid algorithms and implement them in Java. Like problem solving is a very crucial part of this course. Like we're going to solve problems from each and every topic, like hundreds of problems. So like in interviews, you are going to face maybe problems from here only. Like if you're lucky, most of them will be from here only. Then you are going to cover spiral decomposition, price, segmenting, some advanced topics. These are not generally asked interviews, but these are important for competitive programming contests. Then we will cover number theory, problems or interviews. Then the most important topic, recursion and dynamic programming. Okay? We'll cover problem solving. In the last, we are going to cover graph algorithms, very important topic for interviews, and we'll solve a lot of problem solving so that you can solve these problems in interviews as well. So I will show this to you what we have now. At last, we have got this Brahmastra course, which is a 5 months course for placement preparation. The syllabus for this is here. You can look at the. We'll start with the puzzles and maths topics for interviews. Like maths is a very important topic for interviews. Like you can get tricky problems from here. So we cover those. Then we are going to cover sorting and searching. After that, we'll cover bit manipulation, backtracking. Then basic data structures. You can take a look at this. String algorithms, greedy algorithms, game theory, dynamic programming. Then we're covering graph algorithms. And at last, we will dedicate 2 weeks just for problem solving of product based operations. Like all the previous year's questions, we are going to focus on solving them. So most of these problems. So my is a six like a 6 week course for advanced programmers. So this will mainly be covering the advanced topics. Like first we start with some advanced dynamic programming, like advanced GP, then you go to advanced segment trees, like problem solving on them, then you go to graph theory. Finally we go to like mixed problem, that is like combining all these topics and solving problems in all of them like together. Okay. So these are some of our educators. They have been to ICPC World Finals, like Professor Grandmaster, or even they're working at top purpose companies. So the benefit of these classes are that all these are live classes. All the live classes you will get doubt support after the class. If you have any doubts, you can clear your doubts, and you will get like hundreds of problems, more than this already. Hundreds of practice problems on question for each of the topics which we will cover in this class. Like all these topics which are covering here, for each of them you are going to get lots of problems on the question. So you can meet some of our educators. They have been to ICPC World Finals. They're working at maybe LinkedIn, Microsoft. So you can look at their profile later as well. So if you want to register for 1 year, the fees is 30,000, and for 6 months it's 27K. If you register, like if you use my coupon code, then you will get a 10% discount on this price. Okay, and if you are planning, like if you are preparing for interviews and planning to register for it, do it now because soon we'll reduce this discount to 5%, and like it is going to stay for a few more days. So if you are planning to join this course, do this now. Okay. So if you have any doubts in anything, you can ask me till this point, or else what I'll do is I will end this session now. Any doubts? Anyone? Any doubts you have, can tell me, or else let's end this session. Okay. Okay. Let's go through this problem. If you have like any doubts, you can ask me in the next class. We'll be having our class in the next week. If you have any doubts regarding the problems we discussed, you can ask me in the next class. Okay. Okay. Thank you, everyone. Thank you.